Hi, this is Jason Molesky. In this example, we'll take a look at interpreting a p-value. Calcium is a vital nutrient for healthy bones and teeth. The National Institutes of Health, NIH, recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers aren't getting enough calcium. Is this true? Well, researchers want to perform a test of the null hypothesis mu equals 1,300 and the alternative hypothesis mu is less than 1,300, where mu is the true mean daily calcium intake in the population of teenagers. Suppose they ask a random sample of 20 teens to record their food and drink consumption for one day. The researchers then compute the calcium intake for each student. Data analysis reveals that x bar, the sample mean, is 1,198 milligrams, and the sample standard deviation is 411 milligrams. Now, after checking that the conditions were met, researchers performed a significance test and they obtained a p-value of 0.1404. So in this problem, we want to explain what it means for the null hypothesis to be true, and we also want to interpret the p-value in context. Well, in this setting, the null hypothesis is mu equals 1,300. This says that the mean daily calcium intake in the population of teenagers really is 1,300 milligrams. So if the null is true, then the teenagers are getting enough calcium on average. Now, assuming that the daily mean calcium intake in the teen population is 1,300 milligrams, there is a 0.1404 probability, or about a 14% chance of getting a sample mean of 1,198 milligrams or less just by chance in a random sample of 20 teens. Recall that when we interpret a p-value, what we're saying is, assuming the null hypothesis is true, here are the chances we'd actually observe a sample value as extreme or more extreme than the one we saw. In this case, that 14% chance is pretty high, so I don't know that we have enough evidence to reject the null, but we'll learn a bit more about that later. For some additional practice with interpreting a p-value, try exercise 11. Hi, this is Jason Molesky. In this example, we'll take a look at the concept of statistical significance. A company's developed a new deluxe AAA battery that's supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company wants to be convinced that they really do last longer. Well, based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. The company selects a simple random sample of 15 new batteries and uses them continuously until they're completely drained. The sample mean lifetime is x bar equals 33.9 hours. Now, a significance test is performed using the following hypotheses. The null hypothesis is that mu equals 30 hours, and the alternative hypothesis is that mu is greater than 30 hours, where mu is the true mean lifetime of the new deluxe AAA batteries. Now, let's suppose the resulting p-value is 0.0729. Well, what conclusion would you make for each of the following significance levels? Suppose we looked at alpha equals 0.10. Well, because the p-value 0.0729 is less than alpha equals 0.10, we reject the null hypothesis. That is, we have convincing evidence that the company's deluxe AAA batteries last longer than 30 hours on average. Well, let's suppose alpha was 5% or 0.05. In this case, because the p-value is greater than alpha equals 0.05, we fail to reject the null hypothesis. That is, we do not have convincing evidence that the company's deluxe AAA batteries last longer than 30 hours on average. For some additional practice with the concept of statistical significance, try exercise 13.
Hi, this is Paul Buckley. In this exercise, we'll interpret both a null hypothesis and a p-value in context. Using the example from exercise number 1, the survey of study habits and attitudes is a psychological test that measures students' attitude towards school and study habits. A teacher gave this to a simple random sample of 45 of the over 1,000 students at her college who are at least 30 years of age. She suspected that older students have a better attitude towards school. In her sample, the average sample score was 125.7 and the sample standard deviation was 29.8. The significance test yielded a p-value of 0.0101. Our first question is to interpret the null hypothesis. We were given that a null hypothesis, mu, is 115, where mu is the average score for all U.S. college students at least 30 years of age. The alternative was that mu is greater than 115. If our null hypothesis is true, then in fact the mean SSHA for students at least 30 years of age is 115. This would mean that the attitudes of older students doesn't differ from other students on average. What the p-value is telling us, to interpret the p-value, this says that assuming that the mean score is in fact 115, then there is about a 0.0101 probability of getting a sample mean of at least 125.7 just by chance in a simple random sample of 45 older students.